Okay, so this is the compressor that you saw me change out a couple of videos ago in that condensing unit. And I basically gave it a haircut down to the weld line here. And we're going to open it up and we're going to see if we can actually find the failure mode in it. Now, unfortunately, I still have the starting components. And I could have sworn I kept the capacitor to this, but I can't seem to find that. So let me just go through how I diagnose this as a bad compressor really quick. So it showed up at the job site. They said the refrigerator wasn't working. Went to it, found the unit. Unit was unplugged. Plugged the unit in. Everything, all the lights and everything turn on. The condenser fan motor starts, but my compressor doesn't start. On 99% of refrigeration units, if your condenser fan motor should be on when your compressor's on. One pretty standard difference to that rule is, say, an open case, like those things that you see at grocery stores or at gas stations where it's like a giant open case and you just reach in there and grab a drink. There's usually drinks or snacks or sandwiches in there. Usually those condenser fan motors are on all the time to allow air to circulate behind it, because the way that they're set up, it kind of sucks air in through the front and blows it around the back. So usually those condenser fan motors are on all the time to keep the compressor cool. But on your smaller, normal refrigeration units, whenever this compressor is running, that condenser fan motor should be on, and vice versa. So I immediately knew something was wrong with the compressor. Now the weird thing is, usually you'll put your hand on it and this thing will be smoking hot, and it'll be going out on internal overload, which is this guy here. And you'll be able to hear it hum and then click. That's this overload heating up. There's a bimetal strip in here. When it heats up, it snaps contacts open. Now, this should be closed all the time. This one, when I tested it, okay, you can see me touching both terminals there. No noise yet, and I have noise when I have continuity. So this that I just dropped on the floor, this overload itself is bad. So what I did is pulled off the relay, the overload, and the capacitor, which would be sitting up here, and I put on a 3-in-1 relay. If you don't know what one of those is, take a look at take a look at this video up here that kind of shows what it is, and that will also show how this relay works to start the compressor. So I put the 3-in-1 on there. Well, first I double checked and made sure I had continuity between these windings. So there's one start winding, this terminal here. Let me get you guys down so you can see a little bit better. Maybe get some light in there. Hopefully that shows up on camera there. So this terminal right here is common, and if you look at the relay here, it says S and M. So main, M is main winding, which is run. S is start winding, which is start. So you go from common to start, I get continuity, and common to run, I get continuity there. In between run and start, I get continuity because it's going all the way through. So I know that my windings are at least intact. So I installed my 3-in-1 like I normally would, started the unit up or plugged it in, and I could just hear it hum, try to start, and it wouldn't do anything else. And it was drawing a ton of amperage, so I unplugged it before it would trip the breaker. And basically then we know we have a dead compressor, because even if that 3-in-1 won't turn it over, buying the exact start and run components there won't help you. So what I want to do real quick is I want to see how nasty this. One good thing is if we did have the capacitor, we could test that and determine if the capacitor itself was bad. But obviously my 3-in-1 was brand new. I know the capacitor is good in that, so even if the old one was bad, it still should have started with the new capacitor. Alright, so you can see our relay in here is pretty crispy. Okay, you can see that, so that's not particularly healthy. And what I'm very interested to see is what this looks like in here. Okay, so there is my overload. You can see it's actually right here. right here and here are the two contacts, okay? You see that one's melted away. In this strip, when this heats up, this bends and it pulls the contacts away from this side and this side. Let me see if I can actually get this little strip out of here without destroying it. Okay, so I got it taken down enough to where you can see a set of contacts here, and hopefully it's just still good enough to be able to pop. So here's our heat source. Alright, it just snapped. I just heard it. This might be too far gone to snap open all the way. But I don't know if you can see the way it looks now. See how it's curved and dished up? It'll cool off. Give it a few seconds. There it goes. See it snap down? Let's try that again. There's a snap there. That would open the contacts and you'll see it cool down. And it's cooled down. So when you hear the compressor try to start and hum and then click, this is what you hear clicking. Okay, so now we're going to go into a teardown and kind of see if we can see what killed this. So I'm going to take this off. And there's a compressor there. So it doesn't feel really gritty. It doesn't feel too bad. I mean, if it was jammed up, I literally had to manhandle the crap out of this and it was vibrating like crazy to get this cut off, so it could have loosened something up at that point. But let's see how this is actually made up. So this is the top. You can see this little doohickey kind of in there. That looks like it goes right over where the shaft is, but you can see the size difference. So it's kind of meant to float around in there and not necessarily hold it in line. You can see that this is on springs. Okay. Now another thing that you can see here is it went on right like this, right like that. And this is where the suction line comes in. And that suction line goes just about into that port there. And this here is plastic. It's probably some sort of high temperature, high impact plastic. Exactly what kind, couldn't tell you. But you can see that when you charge this, you want to make sure that you don't slug liquid back to the compressor, because obviously it'll go right into here, and this goes right down. We'll see where that goes after we take this all apart. But you can actually blow the oil out of the compressor and seize it. So this tube right here is our process tube, and all this does is it goes right into the case here. Same as the suction line, but it's just directly into the case. It's just sensing the pressure, or it's open to the pressure of the actual case itself. It doesn't have any kind of plastic setup like this. And I'm assuming this is to direct most of the oil that's coming back to the compressor into a specific spot on the compressor, but we'll get to that when we take it out. This here is the discharge line, so it's coming off the side of the compressor inside there, which you probably can't see yet, coming up and around and going right out here. Now this is that's copper line that's silver soldered here. That's silver soldered there and silver soldered here to a stub that comes out. You can see this little spring on here, almost like a bending spring that we would use to bend copper. I don't know if that's just to provide more I wonder why they would put that on there. To hold this band. I mean, it doesn't go all the way around. Was that something that they used to bend it at the factory so that they didn't kink this and they just leave it on there? Or does that serve a specific purpose? I couldn't tell you. But either way, what we're going to do is we're going to just snip this pressure outlet right here. Alright, so that just disconnected me from this port. And we're going to see if we can lift this right out, and we can. So there are three. There's a connector down there that's connected to these electrical connections here. So let me grab a flathead, see if we pry those off. Okay, so now that's off. Now this whole thing should come right out. And it does. Okay. Okay. So, I mean, the oil doesn't look too bad. It's got a little bit of haze to it. And, I mean, it's also been open for 4 days. But when we did our test, it showed up as passable. Here's one of the springs. You can see it sits on these 4 little springs here, spring mounts. Okay, so let me get a towel. Okay, so first things first, why don't we take a look at the heart of this. So we're going to take off this plate, which covers where the piston is, basically the head. So behind here should be a set of valves. Alright, so there's that little suction tube, and there are my valves, my valve plate. So this little plastic guy. Alright, so all this does is funnel into here, into that center port, and this plate should pop off. Okay, so let's get this cleaned up a little bit. So these are reed valves. The way this works is right here, it's at the top, the piston's at the top of its stroke. So as it goes down, it's going to draw this valve in and draw refrigerant gas vapor into the compressor. As it does that, these valves here, you can see spring pressures on this side, are going to close. When it starts its compression stroke, it's going to compress up, push up on these 2 ports, which will lift up this spring and allow the refrigerant to come out. So let me see if I can seal this enough to make it do it. Make it move a little bit here. I might not be able to get good enough seal, but we'll give it a shot. Alright, you can see that valve there fluttering a little bit. I can't get a good enough seal to push these 2 ports off, but that's how that works. So a lot of times you can warp these valves too, and that's how a compressor becomes equalized. You put your gauges on there, and it'll basically be running but moving no refrigerant. And often you'll hear a loud hiss. So that is basically all you're working. And so you got some black schmoo in there. See, the funny thing is I didn't find any of that in the rest of the system. And when I did the acid test, it came out as okay. So, as far as the cylinder wall goes, it doesn't look too bad. You know, there's no real gouge in there. So now, this sits in there like so. So the refrigerant comes through these 2 valves into this chamber here, which then allows it to go. This is sitting there. It allows it to go through here into this port here, which goes into this first little ball. So like I said, I've never really seen these little chambers before, so I'm interested to see what the hell's behind them. Basically a whole lot of nothing. Looks to be able to hold oil, to push the oil through the system, have something to do with oil circulation throughout the system. It's the only thing I can come up with. Because you're going to get discharge of oil and refrigerant into here. I'm not exactly sure what the purpose of these 2 things are, but it comes through this port into this first chamber, from that first chamber across this steel line into this chamber, and then out the discharge line. You can see this tube here is steel, this tube here is copper. They're just silver soldered in place. So now we can probably disconnect the motor here. take the windings right out of this. Here's the windings. So got a little bit of play there. Nothing I would be super concerned about. You can see a little oil pickup here, which comes down the middle, and I don't think that tube goes all the way down. I think that's just there to disturb the oil, just to mix it around and sling it. It doesn't look like it's, or if, I can't really tell if it's picking it up anywhere to send it up here. That's just sitting on there. Looks like this is, that's got to be pressed. It looks like it was rubbing. I'll be honest with you. That's what it looks like. Maybe it jammed itself. Yeah, I think that's what it did. Because if you look at, you got dull, and then shiny in the middle. And I can feel it with my finger. You can feel the laminations here, and it's a lot smoother in the middle and not so much here. So maybe this was whacking the crap out of the inside of this. Yeah, it was. Yep, that's exactly what it did. That's exactly. I'll get a good up close of that. So I think from me taking this apart, it actually unstuck itself. But let's see if I can get this out. Okay, so I'm not sure how exactly this little eccentric is held on to the main shaft. I pulled out that little slinger, and doesn't seem to be any fastener down the end there. So I figured I'd just try to drill that out, but this is hardened, so I can't get through that. So what I did is there was a spring pin right in that hole that held the wrist pin in, and there's a hole on the other side that lines up with the wrist pin. So if I need to get a punch, I will, but hopefully I can just get it by hand. And yeah, it moved. Let me get a bigger Allen here, just something I could push against. Okay. Here's the wrist pin. Now we can just pull the piston right out. And there's your little piston. So no rings or anything. There's the top of it there. It's still nice and shiny. There's nothing wrong with this. There's no real scoring. I mean, it has wear, but obviously it's a piston going up and down. It's going to have some wear. But as far as any kind of scoring or anything, that thing looks beautiful. And just for peace of mind, yeah, that's not hardened at all. So that's where the pin went in, right through that little hole. And I don't see any provision for any oiling there. And I don't see any see if I can get this. Alright, this connecting rod won't come out. It's not going to be able to come out because I can't clear that. But what I'm looking for, oh, actually it can come out like that. There you go. So there's your little connecting rod with the piston. Okay, so there's just a slot to allow oil in there. I don't know if that comes in on camera. Let me zoom in a little bit here. It's kind of hard because I'm just looking through the viewfinder of my camera, so bear with me here. So there, you can see a little slot for the oil there. There's also a little slot where that pin is. Here is the piston. And yeah, so there is a hole here that goes up through here and then out the top. So there's our provision for oil, which means that the tube that went in here does pick up oil to allow it. There's probably a slot in here. Yep, there it is right there. So there's a slot and a hole right there, which allows oiling of that bearing surface, and which will allow oil to come up the inside of the connecting rod into where that pin is. And like I said, I'm not exactly sure how. So the way this looks like, this eccentric is in there. This is part of this shaft, this whole shaft. Alright, so what they, yeah, that's probably what they do. That's probably what they do. So they probably insert this entire shaft from this direction here. This has a keyway in it. Probably insert the entire shaft from this direction here, straight down. Let the eccentric sit here, and then take the rotor and place it over it. This edge here, right in here, looks like it's folded over and down. If I look diagonally, there's a key slot right here. And yeah, so this is staked onto it. So that's how they do that. That's how they get this out. And this whole shaft here is hardened. Nice part though. Alright, so let me set up and show you exactly what happened to this. Alright, so this rotor, if you look at it, right here you can see shiny bits, and I can feel a divot worn into it right here, which means that this is actually hitting the motor stator. So if you look, if I can get the light right, you see a shiny spot. So that's right there is where it was impacting. Right there, between here and here. You can see it there. Not so much there, but right in there. You can see it was impacting. So it probably did that enough times and actually got stuck against that. That's what was not allowing me to move, because the windings themselves, I mean, they don't look bad. This is, I mean, it's got some black on it, but it's not burnt. Alright, when if I wipe this off, this wipes right off pretty much in the actual winding itself. And I mean, we electrically proved it also that it's still intact. Now what I'm wondering is, up at the top here we have this little cap. That little cap is where this sits. Somewhat, I might end up blocking it like that, but as you can see, we have a lot of wiggle room there. I don't know if there's supposed to be that much. Like, I don't know if there's supposed to be something in here to hold this a little bit closer. I don't think there is. Just because the only vibration you'll get from this is during usually startup, or enough to make it wobble. You know, I couldn't tell you. But as I said, you know, this is sitting on springs and allowed to vibrate and allowed to move a little bit. So I don't know if this just became unbalanced at some point, something happened to it, but this definitely started hitting the walls of that, and that's what caused our failure. Because there's nothing wrong. This bore here, this bore is also super clean. There's no scoring or anything in there. The valves are still good. Everything still looks okay. So that is definitely our failure, and the unit's still running and running perfectly fine. Everything is at temp. So new compressors in there, and nice and happy with the new dryer. And we put that acid scavenger stuff in there. The new dryer, like I said, most of the debris that this was hitting against was caught in probably the oil and the sump. The filter dryer probably caught whatever rest went through the system, if anything. Obviously our cap tube was not clogged, and so I'm pretty confident we got a good repair. I was just interested to see what actually killed that compressor, and now we know. But there's your little baby piston.